Calorie tracking, recipes, diet plans, water tracking, health planning is simply free. Download the app now. సో ఇప్పటివరకు 30 దేశాలు మాత్రమే కలిగి ఉన్నాయి. మిగతా దేశాల్లో కూడా అక్కడ సభ్యత్వంకి వెళ్ళాలని చూస్తే యూక్రెయిన్ కావచ్చు, స్వీడన్ కావచ్చు, ఫిన్లాండ్ కావచ్చు.
Fine, thank you very much. Thank you.
Good afternoon to everyone. It seems there is some problem in my audio. I'm trying to address it.
Yeah. We can hear you. And it's good evening from me.
Yes, sir.
Good day. Good day. How are you?
Good. Hi, Shiv. Hello.
Nice seeing you. We have to say good night. Nice seeing you.
Well, Jim and I are not very far. I think Jim.
Yeah. No, I'm the nearest near the evening.
Yeah, you're right. We are 7:30.
Yes, we're 9:30 p.m.
Master, good afternoon.
Good afternoon, sir. কেমন আছেন স্যার? ভালো?
Yes.
Thank you, sir, for organizing a very important webinar.
Yeah. Okay. Thank you.
Yes, thanks, Nabanshu, for organizing all that hard work.
Yes, thank you.
So we'll start within 2 minutes. Okay. Then Peter will join. Right? It's okay, Jim?
Yes, that's fine by me.
Jim has grown younger.
Yes, I have. Yeah. There's a story. I had a bit of earlier this year. I had a bit of heart failure. I've been totally cured, and I've grown younger. So it's made a big difference. Orvado Bronini.
Yes,
another person.
Nice to see you.
Yes.
Professor Hattori, all people. Alonso. Good morning.
Good morning.
And good evening for me. What time is it for you, Orvado?
Must be at night, 8 o'clock, 8 p.m.
No, Alonso, that's 5:30 here.
5:30 a.m. Gee.
Yes.
Well, I'm
11:30
p.m.
It's early. It's very early.
Yes.
So, with your due permission, we are going to start today's very important webinar. At the outset, very good afternoon and very good evening to particularly Jim and others, but very good morning to Andrea. Okay.
Yes.
It's very early in the morning, and also Brunei also.
Yeah.
And for others, it is a very good afternoon to all of you. A very warm welcome from INSAM platform, and with all your cooperation, INSAM is exploring and trying to do good work. You can visit the INSAM website. Frequently, we are displaying very important areas. Recently, we have displayed how in Brazil the hydrometeorological, particularly drought, is been monitored and managed. Even also, we have displayed how the South Asia Forum for Agriculture Meteorology is working very nicely. We have one introduction program with Afghanistan, and another shortly will be done in Nepal. So, in addition to this, among others, we are trying to organize a series of webinars so that 2,500 members across the world would be benefited by the experts. And when we are planning to organize the webinar. We are trying what are the emerging issues of agriculture meteorology and how collectively we can work onto that. So today the webinar will be very important topic on impact of climate variability and climate change on agriculture. I think Jim Salinger from New Zealand, he is the exponent of this kind of field, and he worked, I think, last 40 years in different subjects, including the climate change and climate variability. And Jim was also the lead author of the IPCC report, which has been awarded Nobel Prize in this area. To describe Jim, it will take long time, but briefly I'll be telling about Jim. Jim is a climate scientist and expert in climate variability, and Jim has worked in different universities, and he worked in senior research associate in East Anglia University, where I have the privilege to work in climate change unit in East Anglia. And the most worthy is that Jim was the vice president very longer time in the Commission of Agriculture Meteorology in WMO, and WMO has awarded a very exceptional award to Jim, and so many, and we are very delighted to see that Jim has 190 research papers in very peer-reviewed journal. I mean, it is an exemplary for all of us, and 40 years research work. So we are very fortunate today that Jim has consented to be the speaker, a very important topic. Thanks to Jim for your valuable time. So now I'm handing over to Jim to I request him to give in a presentation, and I requesting all of you to just mute your sound so that we can hear Jim nicely, and then we can interact with Jim after his presentation. So over to Jim.
Thank you, Bruce. Now, need to share. I need to find my presentation. Share. So, it's just the one. Nope, you don't want that. I think it's this one. Yeah, there we go. See that? Can you just confirm it? Is that visible to everyone?
Jim, your system is mute.
My system is mute.
You can go to present, then you can share your presentation.
Yes, that's what I was trying to do.
Now you can go.
So, share. Yeah. Technology's got, so can you hear me? And we will try the presentation. Cancel that one. Share window. That's it. Can you see that?
No, we can't.
Okay. Worked before, so cancel that. Present now. I'll just go somewhere else. A window. It's not bringing up.
Jim, any problem?
Well, I'm trying to get
Your sound is mute, Jim.
my sound is mute.
Jim, you open the file before you share it and then share. You can share only open file.
Yep. Okay, I'll cancel that. So I've got present now. Can you hear me?
Yes.
Okay, so I've got present now. Do I push that one?
Jim, we cannot hear you.
You cannot hear me.
I can hear Jim.
Yeah, I also can hear him.
Okay. Well, I've got the microphone on and it's showing sound. Now. So I have to open a file.
Yeah, then go to share.
Then go to
Jim, can you hear me?
Yes, I can. So then I go to share. It's worked before. So I've opened the file. It's a PowerPoint. I can see.
I think we lost connection.
No, the connection's all right. Yes. What do you want me to do? I'm trying to get the presentation.
Why can't you send a mail to Nabasu and he can open from there?
I can email it. It's quite a large file, but I can try. So,
Jim, can you hear us?
yes, I can.
But your sound is muted.
I think you are muted yourself. Just check your volume. Nabasu, check your volume. We all can hear him. You must have pressed the mute button. Nabasu?
Yes. The others can hear me.
Yes, yes.
Yes. So it's just a matter of getting the presentation. Let me see. So, tab. Share.
Can you see the page of Jim?
Okay, so last time this worked. Okay, share. That's not share. This did work. Cancel. Present. So how do I get a PowerPoint presentation to be seen? That's all. Last time it did it. We'll try this. No. Entire screen. Meet.
Hello?
Okay.
नहीं सर एक सेकेंड सर सर आप उनको प्रेजेंटेशन शेयर करने के लिए दीजिए मैं यहाँ से शेयर कर देती हूँ
Options.
मेल करने के लिए बोल दीजिए हाँ so ask him to send the mail I'll share the screen
I'm unmuted.
Hello.
Yes, sorry about that. Now, I've got a PowerPoint presentation here.
Okay.
Got someone here who might be want to put that on the full screen.
Okay, so you want to share your screen?
Yeah.
Right.
Here we are. Someone's helping me.
Like that. Let's see. You tried that one?
It worked before. Then.
Hello, good afternoon.
Yeah, we're just sorting it out now. I can get the PowerPoint up.
I think you better restart. First open
Yep.
the PPT, then you share it and present.
So open the PowerPoint.
Yeah, it's just Zoom's not letting me share the screen for some reason.
Okay.
So I don't think it's the PowerPoint. I think it's the Zoom. So you might need to restart. Yeah.
There we are.
Try this one.
Yeah, that will do it.
This one?
Yep. Let's share.
Okay, yeah,
We're there.
Okay.
Can you see that?
Yeah, I think it's coming out.
It's coming.
Sorry about that.
Yes, of course.
Right. Okay, let's go. Got people from Argentina here. Okay, so apologies for the technology, but that's how it goes.
Jim, we cannot hear you. Unmute your system.
You can't hear me. Oh, now.
You have pressed your mute button. Press your mute button.
Unmute.
No,
Navashu, are you able to hear me?
Oh, you should be able.
You should be able to hear me.
Navashu is not able to hear anyone, so I think.
Yes, press the mute button.
No.
Ask him to increase the volume.
Yeah.
We can only give a message
सर
through
आप
chat
अनम्यूट
and I'll do
कीजिए
that.
और आपका जो कंप्यूटर में नए स्पीकर्स का वॉल्यूम
my
बढ़ाइए सबको सुनाई दे रहा है सिर्फ आपको नहीं सुनाई दे रहा है
Okay.
Okay.
Right. So most people can hear me?
Yeah.
Right.
Yes.
Good. Okay. Well, good evening, good morning, whatever time of day it is. And I'm delighted to be able to talk about increasing climate variability and climate change in agriculture.
Screen sharing stop हो गया.
As you know, when I joined the Commission in 1986, Case was the Vice President then, and then he became President and I became the Vice President. So I worked on climate variability and climate change issues, and Case tend to look at indigenous agriculture. So the outline of this talk, I'll talk about increasing climate variability we've seen, then we'll lead into climate change, and with this comes changes in agriculturally significant extremes. Then I'll go into sustainable agricultural systems. Then we'll look at nature-based solutions, because we really have a world with lots of monocultures, which leads us into all sorts of problems, with all sorts of diseases and pests, and so really a lot of people are now turning to nature-based solutions because they're usually far more sustainable, and then I'll look at the changes required. So firstly, I want to talk about increasing climate variability. This the first thing I'll talk about, after global warming, the most significant feature affecting the climate system, particularly climate variability, is the El Nino Southern Oscillation. And here I've put up an index of it going back to 1870. This is using the Oceanic Nino Index. And as you can see, as you trot along, you can see.
I'm not able to see the PowerPoint presentation by Jim.
You can't see it. Can others see it?
No, we can't see it. Jim.
Nobody
You
can see.
1 second.
It
You
was there earlier, but it went off again.
Oh, okay. Oh dear. It's because we checked the sound. Okay. So I'll just get my help. Lou?
From the years.
Presentation now.
From the years.
Master Ramakrishna garu. వినపడుతుందా మా వాయిస్?
Nabasu, can you hear us?
Okay, see, this is not wrong. That is your opinion that during the
You see it now?
Yeah. Now it's clear.
Yes.
Good. Okay.
Right.
Good.
Great.
It helps to have a younger person here. Okay, so blue are La Nina events and red, particularly when it's above -1 are El Nino events. And if you follow it through from 1870, you'll see that since 1950, both the intensity and of ENSAM events is much higher since 1950. And the next slide shows you it more recently, since 1980. And you can see what's happening is the actual events are much more intense, and the frequencies seems to have increased a little. And why El Nino is important, this just shows you El Nino effect impacts in December and February at the top, and as you can see there, the brown areas are where it's hot and dry, and I'll just see if I can, sorry, I've just made it a bit smaller, but I'll go back in a minute. So brown is hot and dry, and cool is obviously the greeny colours, and warm is the reddy colours. So I'll go back to full screen now. So, oops. So you can see that in the boreal winter, there's quite dramatic effects. That's the austral summer, and it tends to affect all around the Pacific Basin, but even gets to the Atlantic and South Africa. So it's something that's pretty widespread. Now, in the boreal summer, the effects seem to be mainly sort of Southeast Asia, Australia, New Zealand, the Pacific, and some impacts in South America. So it is something that is pretty globally widespread. Now, something that's fairly regional, there are lots of other factors that cause climate variability. For Europe, the North Atlantic Oscillation in winter, that's December to March, you can see there are measurements there. There's been positive trends observed between the 1960s and the early 1990s, but this index has become less positive thereafter. Why it's important, it changes the storm tracks in the North Atlantic. So you can see there that when it's negative, you get much more zonal flow with the storm tracks going into Europe where it's wet, whereas over Britain and Northern Europe it's dry. And you have more low pressure systems near Greenland and the Azores high retreats a bit further south, allowing the storms into basically southern Europe. In the positive mode, the southwesterlies get stronger, so it's wet over northern Europe and dry over the Mediterranean and southern Europe. In the southern hemisphere, we have something called the southern annular mode or the Antarctic oscillation. This has been much affected by El Niños and La Niñas and also global warming. If you look at the black line here, you can see that it's been trending upwards in the second half of the 20th century. And it now falls outside the range of natural climate variability. Why I mention it, I'm being very parochial now because it affects Australia and New Zealand in particular. And in the summer, positive phase, it's actually, which is what we're having this year, gets very wet in eastern Australia, and when it combines with La Nina, which we have this year, you've probably seen the television reports of all the floods in Queensland and New South Wales. And it goes wet in northern New Zealand and dry in southern New Zealand. So the two tend to act together. When it goes into the negative phase, southeast Australia gets much drier than normal. So this is something that has regional impacts, and global warming is affecting it. Now, if we look at what has happened in global climate, so this is the diagram on the left, looks at the last 2,000 years, and you can see how a lot of this would be paleoclimate records, but then there's cooling globally, and so temperatures, not a lot of cooling, but there's a cooler period. And if you look at the current warming, it is unprecedented, certainly in the last 2,000 years, and the rate of change is phenomenal compared with the normal record. So if you take 1850 to 2020, which is this period here, you can see what's happened, and we've had 1.1 degrees centigrade warming since the base period, which is dating as 1850 to 1900. So we're now 1.1 degree up, not far from the 2.5. There are also measurements of extremes, and this is the changes in hot extremes, and North America's over here, South America's here, Africa and Europe, then Asia, and this will be Australia, New Zealand and the Pacific. Now, where you see it's red, it means there's been an increase in hot extremes, and the number of dots show the confidence in the human contribution to the observed change. So you can see in most of the land areas, there's been highly significant or medium significant contribution because of human activities. It's only Southern South America, Central Africa, and it must be US, so the Central North America and Eastern North America, you have low confidence. Everywhere else there's either medium or high confidence. When we look at changes in heavy rainfall, it's not so widespread, but the blue or green represent increases in heavy rainfall, and there seems to be low confidence generally, but where you get increases in heavy rainfall seems to be fairly clear across Northern Europe, Central Europe, and into Asia, and certainly Southeast Asia and Northern Australia, and also Western South Africa and Eastern South Africa, and the southeast of South America. But again, the confidence is not that high, but there seems to be more increase in heavy rainfall. And this is types of observed change in agricultural and ecological drought. You can see the pattern there. Western North America, medium significance in terms of human contribution. Northeastern South America, then it goes Western, Central Europe, certainly the Mediterranean and pushing to the east, and Southern Australia. So not that widespread, but there's some in some areas. Now, when we're looking at the future, it's very important to look at scenarios, and obviously what's going to happen in the future will depend on emissions and obviously human behaviour in terms of basically greenhouse gas emissions, but people always tend to relate it to carbon dioxide. So we're here now, if we can hold warming to 1.5 degrees, so it allows for that. We've already at 1.1 at this point. The ideal is to hold warming to 1.5 degrees. That's been the Paris Agreement. The probability of that is not that high. So the projections are anything from another 0.5 degree warming to 4 degrees warming. And it's important to try and limit things as much as possible because the effects on activities such as agriculture are pretty dramatic. So this shows what happens in terms of additional amounts of global warming changes get larger. Of great importance is you get the largest heating in the high northern latitudes, and that's not surprising because you're melting a lot of ice and turning it into water, and you can see what happens. You get incredible warming in what is the tundra and maybe taiga zones, and you can see even though there's 4 degrees of global warming, you're up to 7 degrees in the high northern hemisphere. And you get a lot of warming in the mid and subtropical latitudes, and obviously the least in the southern oceans. They take a lot to warm up. So hopefully we don't get into a scenario which ends up like this. The other thing that happens is with every additional amount of global warming, the changes in extreme rainfall intensify, because effectively when you heat the atmosphere up, for every degree increase in temperature, the atmosphere holds 7% more water vapour. So when it does rain, then or precipitate, then more comes out. And this is what we've certainly observed with when we get floods these days. You suddenly get the 1 in 100 year flood or 500 year, but that's based on average recurrence intervals that were developed earlier in the 20th century. So those are probably not that relevant anymore. And so you will find that particularly when you're preparing, you've got to prepare for floods. And I guess the prime example is what's been we've been seeing in southeast Australia over this austral or southern summer. And so the human influence is the main driver of hot extremes, which have become more frequent and more intense. I showed you that. A big problem, and I'm not looking at fisheries this time, but is ocean warming since the 1970s, and that causes acidification of the oceans, and that will cause lots of other issues. Remember, the surface of the globe, 70% of it is covered by ocean, so that's very important. We see changes seen in the frozen areas of the planet. There's been huge global retreat of glaciers since 1990s. In New Zealand, for example, we've lost half of our ice mass in the Southern Alps, or ice volume in the Southern Alps, since 1950. So in the last 70 years, there's been huge glacial shrinkage. There's been 40% decrease in Arctic sea ice, with frequent things that you can sail through the northeast passages now in the Arctic, and of course decrease in spring snow cover since the 1950s. So this all affects changes to the water cycle, which is vitally important for everybody. So with more global warming, you get heavier rainfall, which is what we see, but at the same time, we get intensifying dry seasons and drought. This is because the evapotranspiration rates go up, and so with that and more heat, you lose more moisture into the atmosphere, which can hold more. So in a sense, you rev up the hydrological cycle. And this graphic really looks at what might happen what has happened in terms of stress because of there's two case studies done. This is stress to date, and this shows yield constraint scores for soybeans and wheat. And you can, if you look at that, that's adding up soil nutrients, pests and diseases, heat stress, aridity, and they've put an ozone. So you add that all up for soybeans, you find there's sort of medium stress, and certainly in Brazil and into northern Argentina and in eastern US, and certainly into the monsoon areas of Asia and in Indonesia. In terms of wheat, which is more a mid-latitude crop, certainly the Mediterranean areas show extreme heat stress, and into the Middle East and into Pakistan, high stress. Then lower stress, but still more stress right across Europe and into Western Asia and northern China area. So that's at the moment with the amount of climate change we've had. So if we look at the moment, the projected impacts of climate change on different cropping systems, and along down here is the type of crop: vegetable, legumes, leafy crops, soft fruit, root crops, tree fruits and nuts. You can see there's varying impacts. So there's climate change in general, temperature including heat stress, precipitation including drought, phenology and seasons. So phenology, most of you will know this anyway, is the change in behaviour, like when crops flower and when you have fruit set or grain set and so on. And then that shows you pests and diseases, ecosystem service, and combine some of all drivers. So looking at for each group, generally vegetable crops neutral, leafy crops and soft fruits negative, but very, very negative effects on tree fruits and nuts, and generally negative on them. So that's showing you some of the stresses to date. Now, what I want to look at is, what do we do about this? And this is where adaptation is so vitally important. So people have been looking at adaptation, in other words, making crops much more resilient to climate variability and change. So firstly, there's use of improved seeds. So you want to have seeds that are appropriate for the soil and climate conditions, and also local breeding of seeds should ensure no negative environmental externalities. But then you have the hierarchical heirloom seeds, which, I mean, wheat, for example, is a highly developed crop through breeding, so that you get the maximum grain weight, but of course it mightn't be so well adapted to the current climate. If the climate gets a lot windier, you'll get the crop blown over and all that. So the highly breeded monocultures may not be the best type of seeds for as the climate changes. You might want something that perhaps produces less but is much more resilient. Soil and water management, of course, and this is where actively aims to protect the soil and thus have positive environmental effects. So there's things like mulching and technical assistance to select the most appropriate mechanism and how to apply it. So soil and water management is also important. As the climate changes, timing of farming practices is important. So you want to link, when you're sowing crops, you want to link the phenology so that it matches the climate. So if the climate is warming, you can do two things. Firstly, you can change your sowing date and harvest dates, and this is vitally important. The other thing is you might use different varieties which are more suited for how the climate is moving. And then there's changing crop livestock distribution and densities. So this is, you need availability of required inputs, that's seeds and manure, technical assistance to make appropriate selection for the biophysical environment, and whether there's obviously cropping densities that you want them to be compatible with environmental resource and availability. The next thing is tillage and associated practices. You have these days the development of no-till agriculture. You want to have positive impacts on soil moisture content and obviously accessibility of planting and machinery. So there are a number of things that can be done here. And of course, crop and livestock diversification. So this is where you might have a mixture instead of having the large monocultures that people quite often have. And the issue is there, as soon as you get a disease into it, it will sweep through the monoculture, whereas having more of a mixed landscape with crops and livestock, very diversification, that bodes well for the future. Now, what I want to do is go into nature-based solutions, and this is also leads to regenerative agricultural, much more sustainable systems. And when you go back into the past, that's basically what historically populations had, because they didn't have fertilizers, they didn't have, well, they certainly had water management, but they had to do everything in balance. Now, if you were lucky, like lived in the Nile Valley, where you got an annual flood which brought down more nutrients, etc., you were lucky. But a lot of people throughout the Middle East and Africa and Asia didn't have such beneficial systems. So that's why you had a lot of early development of human populations along the Nile Valley. So firstly, one is grazing optimization, and this really, you have livestock that exploit the inherent capacity of grasses and legumes, and then, but you also have, you graze to such an extent that you don't graze to the ground, but then you have the livestock which leaves some foliage there so that the grasses and legumes can bounce back. And you see the image on the right showing happy cows and happy pastures, which is what you want to achieve. Next comes the improved rice cultivation management, and this dryland rice, and this is where water management of rice fields, which are quite large methane producers, and by the way, since 2007, methane has been spiking upwards dramatically. Part of the reason is agriculture, but there's other reasons as well. So methane emissions with the correct sort of water management of rice fields can reduce methane emissions as much as 90% instead of having full flooding, and this practice also increases rice yields. So you have a win-win situation there. The next type of nature-based solutions involves proper rate of application and using the proper type of nutrients appropriately and at the correct time. I know in my own country there's been so much, you pour on the nitrate fertilizers, then what happens? This leaches through the soils and gets into the waterways, and it's you then have issues in the waterways. So really, whatever you use, and we're talking now of natural fertilizers, not just synthetic ones, which are particularly bad, then you control the rate. Now, biochar is a very interesting substance, and you can see on the right there's someone holding it in their hands. It's a charcoal-like substance that's made by burning organic material from agricultural wastes by pyrolysis. So you end up with this dense amount of carbon, which then removes carbon from the system. So it's a way of storing carbon, and you can lay it down or whatever. And so that's one way of you're driving out the moisture and other chemicals from the agricultural waste, and you're ending up with solid carbon. So that's a good way to get carbon dioxide and other things out of the system. Nature-based solutions. There's conservation agriculture, and this is important. The sustainable farming method is based on crop diversification, so you don't have monocultures there, you have a range of crops, and you uses the no-dig type of tillage and keeping a permanent soil cover. So with this, you actually conserve. Next thing is very important, trees and croplands. And when you have a mixture of trees and crops, trees can store vast amounts of carbon, and they also provide shelter, prevent erosion, and you get diversity of production, and you can maintain moisture levels much better. So again, agroforestry is another way to go, and it's a natural solution. People have been too rapid to drain wetlands and peatlands. These are another good store for carbon and carbon sinks. They lock up peat wetlands, and particularly their super carbon sinks, and they hold twice as much carbon as all of the world's forests combined and cover about 3% of the Earth's land surface. So instead of draining wetlands and peatlands, they're best left to be there. So you have this huge carbon store. And finally, for the drier areas like Australia, Canada, wherever, bushfire management plan is very important, because bushfires are a huge risk for agriculture. So you need to stop letting some areas go up in flames with the forestry. And I'm thinking particularly of North America, and of course obviously in Australia where that happens. So this shows some of the nature-based solutions and the areas affected. So the first one, grazing optimization. You can see there that you improve animal grazing intensity, pasture management and feed practices to reduce greenhouse gases, and 1.4 billion head of cattle of potential, which is 90% of the cattle on Earth. Improved rice cultivation, so that's really, instead of flooding rice paddies, you actually control the amount of water, improve drainage, and the benefit cost ratio, water quality is improved, seems to be 3:1. So biochar is very important in increasing carbon storage, and so there's a potential there to store 1,100 million tonnes of carbon dioxide a year. So that's a huge amount. Cropland nutrient management, so you reduce excessive fertiliser and other additives and remove perverse incentives to increase fertiliser use. So take out all the subsidies, and so you can get about 44 million tonnes of nitrogen per year production. Conservation agriculture, so cultivate additional cover crops and fallow period, shift to reduce or zero tillage. So with that, 4.8 billion hectares of conservation land. Tree crops and croplands, you can promote integration of trees into agricultural lands, and it increases habitat value. So you're looking at 1,040 million tonnes of carbon dioxide stored a year. And finally, improve plantations, extend harvest rotation lengths on intensively managed production forests. So 257 million hectares. And you can see the little squares. If they're orange, as here, they're all through these, they're important for the climate. If they're this colour, which is bluey green, it's going to be important for biodiversity. And then you have effects on the soil and air. So nature-based solutions are going to have a very positive effect on the environment. And this graphic here is showing various nature-based solutions and what they will improve. So you've got surface water quality, groundwater quality, floods, water scarcity. So I won't go through these ones because these slides will be available after. So some concluding remarks. Climate variability is on the increase with both global, that's El Nino Southern Oscillation, and regional modes. There are lots of other modes which I haven't mentioned, but I just wanted to give you examples of some more well-known ones, especially El Nino Southern Oscillations. Up to 2020, temperatures have increased 1.1 degrees centigrade compared with the 1850 to 1900 period. Significant increase in heat waves and increases in extreme rainfalls with regional increases in drought and dry spells. With projected global warming, temperatures globally are projected to increase between another half a degree to 4 degrees centigrade by 2100, with significant increases in heat waves and heavy rainfall events and intensification of dry seasons and drought. And this is the final slide. So increases in pests and diseases, aridity and heat stress have decreased yields in many crops, especially in subtropical, monsoony and Mediterranean regions owing to global warming. Adaptation measures, so I mentioned improved seeds, heirloom seeds, soil and water management, timing of activities and changing of crops and livestock with diversification. But we can do a lot. The largest improvements in resilience occur with nature-based solutions. So there's grazing optimization, improved rice cultivation, use of biochar, improved crop nutrition, conservation agriculture, trees and cropland, and improved plant management. And I'll leave it there and say thank you. I'll get back to the. Here we go.
Yeah, thank you, Jim, for wonderful presentations. In the flyer, we have mentioned that we are entering to the era of climate change.
Yeah.
Particularly, very predominantly after 2020s. From your presentation, it's very clear now that this subject is very, in future it has to be dealt in a very systematic way. Jim, you have covered very systematically from the ancient times how the temperatures were there, and suddenly how from 1950s, particularly in 2000, how it has been increased very substantially. And you have categorically mentioned that from 1.5 even 4 degree rise in temperature, even you said that maybe 7 degree also, some projections are there. And this is a very cause of concern to all our agriculture fraternity. But you have systematically mentioned that what will be the extremes then. But your last slides, which is nature based adaptations, which is very interesting, particularly in terms of biochar you have mentioned, which will be a very as a resilient agriculture, it will be one of the very innovative methods will be there. I think that you have given a very comprehensive ideas. How the full the world will be moving next 50 years or like that. So I think that all the who has participated, they have enjoyed. Now the forum is open. Now you can ask Jim any clarification or if there any question to it. So over to all of you.
Thank you, Nabasu. Thank you very much, and very nice presentation and from Jim, and it was really enlightening to me. Jim, you talked about and so then a lot of work is being done on east-west circulation, land, ocean interactions, but there is also emerging thoughts that north-south circulations are also being modified because of the warming. And do you think the Hadley cell is shrinking, and also because the magnification or shrinking of east-west, north-south circulation also has a lot of meaning on the mid-latitude westerlies, which bring weather to Europe and also protrude down to the south in Africa and Asian regions, and also has a lot of bearing on the subpolar region and things like that. What is your opinion on the north-south circulation and changes related to the global warming? Over to Jim.
Okay. Well, of course, we're dealing with two hemispheres, as you know, and when you look at what happens in the northern hemisphere, it's quite different to the southern hemisphere. Particularly when you get into the northern summer, it's very interesting, the whole circulation collapses because the Arctic, which is ice covered, all the ice disappears. So you lose the temperature gradient between the North Pole and the mid-latitudes and even subtropics. And so that circulation just slackens and you get these huge wave-like patterns, which you've seen many years, and you get very high temperatures in strange places. Southern hemisphere acts differently. And this is why the southern annular mode is increased. In the southern hemisphere, you have a huge ice sheet, which is 2 kilometres deep at least. In the summer, it's still there. And what people don't realise, and this is picked up with the increasing southern annular mode, is when you heat up the southern tropics and subtropics, you're actually increasing the temperature gradient in the southern summer, so the westerlies get more vigorous. It's the opposite of the northern hemisphere. So the two hemispheres behave differently, and that's why the southern annular mode is increasing. I don't know what effect it might be having on ENSO or anything, but ENSO seems to be a fairly permanent feature of atmospheric variability. After global warming, it's sort of the main feature which can determine whether you have hot or cold years. I hope that's gone some way to answering it. Rotori.
Thank you, Jim. I have another question that is related to Indian Ocean, and because that has a pronounced influence on the monsoon.
Oh, yes.
And the Indian Ocean dipole.
That's right.
Is also, I think, becoming more prominent time. And is that a purely oceanic phenomena or more of an interrelationship between land-ocean interaction?
That seems to be, well, it does. It's another of these atmospheric ocean phenomena. So explain, you get, the way it works, you have off northwestern Australia, you have warmer water, and in the southeast Indian Ocean you can have colder water, and you can have oscillation between the two, and that certainly changes weather patterns, certainly across Australia. It's called the Indian Ocean Dipole. I'm not familiar what it does to India, I'm sorry, I can look that up. And the Bureau of Meteorology website is bom.gov.au, so bom.gov.au. If you go into the Indian Ocean Dipole, search for that, they have lots of good graphics and explanations there. I'm not, without going there, I don't know, I can't answer you how it may affect the Indian Ocean monsoon, but I'm sure it does. So go to the Bureau of Meteorology's website and just put in an Indian Ocean dipole and it will take you to it, and they'll even tell you what phase it's in, whether it's positive, negative, whatever. But it is important. in around the Indian Ocean basin.
Thank you, Jim, for guiding. Thank you very much.
No, you're welcome.
Jim, I have this query to you. Just like Dr. Rathore has mentioned that Indian Ocean, in IPCC's statement, it is there that Indian Ocean is warming, and it will warm very substantially next 50 years. And it has been anticipated that the cyclone will be very severe. Cyclone will be there, and the intensities will be very high. And if you see, if that is the picture, then in South Asia, particularly coastal area, will be hugely affected. So at this juncture, what could be the policy framework will be there in the country, so that they can take some kind of strategies so that how to counteract this kind of activities as far the projection is concerned. What message should go to the countries so that they can a very strategical implementation well in ahead, because it is over to you, Jim.
Yes, okay, well, as you know, tropical cyclones, typhoons, hurricanes, whatever you want to name them, are very dramatic weather systems. They're very powerful. They produce huge winds and very heavy rainfall. So I think the best strategy is to look to the countries that currently receive a lot, and you've got the Caribbean, and that probably has the longest history. And the thing would be to look at how countries there prepare for, in case of North America, they call them hurricanes, hurricane preparedness. There's a whole lot of strategies, and they're well developed. They're developed in the South Pacific as well, because Fiji is another example where it can get battered by, we call them tropical cyclones in this part of the world, and of course Northern Australia. So I think the best thing would be to look at what strategies, well, there's the meteorological organisations, and it's very well developed with the forecasting centres, what they do and their responsibilities. Then they usually feed into the, in Australians' case, the state emergency services. In Fiji's, it'll be into the sort of disaster management areas. So I would take the lead from those countries that currently get them and prepare for them. And probably USA, Australia, Fiji, they're all good examples, because they've spent a lot of time developing strategies.
Thank you.
Jim, can I ask you a simple question? I just looked at this Samsung from Western Sydney University.
Yep.
Sydney.
Yep.
I just read in your biography, which Nabanshu shared, that you have had some work in the Pacific Islands.
Yes.
Okay. Now, we have developed some interest recently. We got a project funded by European source, which is FALA, Family Farming, Lifestyle and Health. It's a group of people from Europe, Australia, 5 or 6 universities, and 5 countries from these islands like Fiji, Solomon Island, New Caledonia, and Vanuatu. Now, I'm part of the project and looking at the linkage about the climate and agriculture, food, and then of course lifestyle and health issues, right? That's broad.
Yeah.
A number of people, like maybe 100 people from so many countries involved in this. I'm just one humble member in that group. Now, my interest is about the latest information, what's happening in the pace of the climate variability, of course, climate change, but climate variability in terms of the agricultural production. And I gave a seminar last week or week two before in the webinar group. Now, I met a couple of people from South Pacific University. Williams he's one of those people who got a number of projects in that space. But just I'm asking you, what has been your latest information that you have in one of those countries, either Fiji or Solomon Islands, and any comments that you want to make about their issues? And their production system is much different than I understand.
Yeah.
I've never visited them, but I have been working with some students and all that.
Yeah.
Anything that you can share, and I do know that New Zealand has more interest in those spaces than in Australia.
Yeah.
So for many reasons, I can understand. So if you can say briefly, I'll get in touch with you later on. But if you can say something that you think would be useful for us, an agroclimatologist, to work there in that space.
Yes. Okay. Well, after World War II, basically, New Zealand ran the meteorological services of a lot of the islands, particularly the Polynesian Pacific. Australia tended to be more into Micronesia. And slowly these nations assumed independence, and so we would try and work and support them. I instituted about year 2000 is something called the Island Climate Update, and what we did is we had this, bit like this talk, we had this teleconference, and we had people as far as NOAA in the east and Bureau of Meteorology in the west. And we connected up with a lot of Pacific islands like Hawaii, New Caledonia, and all the small ones. And we had a good climate talk once a month. I think NIWA still does it. So that, so we wanted this model of a virtual climate centre because you can't physically do it. So we started in the days of telecoms, and of course now with Zoom. So, and that worked well with the meteorological organisations. Now, how much connection they have with the local agriculturalists, I don't know. But I tended to work with the climate people on that. But yes, sure. So you're earlier in the evening at me. You just connect with me and I'd be more than happy to work with you on that.
Thank you, Jim. I'll get in touch with you.
Yeah, good.
Right.
Jim, I would like to congratulate you for the nice presentation.
Thanks, sir.
Yeah, one thing that I just want to, you mentioned in one of the last slides that by 2100, the temperature is going to be between 0.5 and 4 degrees centigrade. So I think one of the most important things that we should do now is to really motivate our younger generations to take appropriate action. So it is very, very important. How can we really motivate the younger generations, make them really realize what is happening, what kind of action they should take? Because 4 degrees centigrade from now
that's horrendous.
is enormous. Even 2 degrees day will be very, very bad. So how can, what do we need to do to motivate the younger generations to take appropriate action right now?
Okay, well, it's actually quite simple, sure. I've been working with a 20-year-old here, and I reckon she's better than Greta Thunberg. Anyway, she motivated, okay, New Zealand population's 5 million. She motivated 170,000 school children into climate strikes around the country. And I reckon she at 20 is already into local government. I think she'll be a prime minister at some stage. You find the young are very motivated because, well, in our system, they know all about global warming and they want action now. So my suggestion is partner up with these young folk. It works very well. It keeps you young too. What they do is they do a lot of the heavy lifting that we can't do. And I hit on the idea once I saw David Attenborough pair up with Greta Thunberg. Once you get that, then you get people in between. You can get a whole intergenerational motivation going. And they like the mentoring we give them because we can tell them all about it and what nasty things corporates did to us and all the usual stuff. So I found the 20-year-olds highly motivated. Our kids weren't. This group are. I don't know what it's like in other countries, but so I pair up with Sophie Handford here, and we've got a good team now, and they're all doing very positive things. It keeps you positive too, because you know how long we've been trying. So that would be my suggestion. I'm finding it's working very well here. I think, Shiv, you'll be able to identify in the community. They're climate activists, but they don't do stupid things. They're really good. I hope that's a positive suggestion.
Jim, I have a comment and a small question. This is Rama.
Yes, hi Rama.
You made a very interesting observation about biochar in your nature-based solutions. We did some work with biochar, but somehow people are not really convinced with biochar because they feel that during the first year the yield comes down when you apply biochar. So I was studying this problem. I find that biochar is made of from pyrolysis. So this is almost like a sterilized product. So we have a lot of pores in that biochar, but there's nothing inside that. So when you apply in the soil, it tries to pick up the nutrition from the soil in the first year to get itself saturated. Then it starts giving this impact on the crop. So what we did is, before applying the biochar, we have mixed it with the farmyard manure for 15 days and then applied it. Then you find the response is quick. Immediately you get a response, a positive response. This is just a point I would like to make. With
very
biochar,
useful.
you can really promote it. It's very useful, but somehow it's not really picking up in India. The second, the small question I have is, talking about this Madden-Julian oscillation, MJO. It's very important to India because it's a medium duration cycle, which has a lot of influence on monsoon.
That's right.
Now, similarly, ENSO also has some influence on the Indian flood or drought situations. If we look at Indian rainfall pattern for the last 130 years, where IMD declares plus or minus 10% as normal, above plus as surplus, or below minus 10 as deficit, you find all El Nino years, they come under normal to below normal years. Not even 1 year is a surplus year. And if you take La Nina, all are normal to above normal, never a deficit year. In the last 130 years. It's a really interesting feature.
So say that again.
Can these two have any relation? This MJO and El Nino. What is the impact of these two?
So just run. So El Nino years. So what were the two facts?
How they interact between themselves. This when ENSO is there, how does
Yes.
the MJO behave?
Okay. Right. As far as I know, is the MJO starts off Africa, then sort of migrates along the tropics and through the maritime continent, which is Indonesia, and ends up in the Pacific and migrates east. And basically, as it's passing, it seems to stimulate convection, and certainly once it gets into the Pacific base, well, it will kick off the Australian monsoon. I know that much. I'm not sure what it does further west. It's certainly, again, the Bureau of Meteorology will have quite a bit on the MJO, and it works out which phase it's in. Now, what's happening? You're sharing your screen with everyone. What happened there? Can you see me? Not sure what's happened.
Yes, we can see and hear you.
Oh, good. My screen's gone a bit funny. Anyway, so talking about MJO, so it's basically convective pattern, and it drifts along the tropics and sets off convection, and probably as well it will kick off monsoonal activity. It certainly kicks off, we seem to be back to normal now, it kicks off the Australian monsoon, so I'm sure it must have an effect on the Indian monsoon. Relationships with ENSO, I don't know. Have a look at the Bureau of Meteorology site. They've got a lot on the Madden-Julian oscillation as well. And it's Guy Wheeler that does the research on it. Hope that's helpful.
Thank you.
You're welcome.
Any question from any?
Yes.
Yeah.
Dear Professor Salinger, thank you very much for your nice and excellent presentation.
Thank you.
I have a question. As we know, you have many experiences in climate change studies. I want to know, have you used any crop models in your studies for when you were studying the effect of climate change on crops and plants? And if yes, which model did you use? Thank you very much.
No, I haven't. So it's more that I linked with friends in the field that have used crop models. So I don't have any knowledge to add in that area. So
But in the IPCC studies, maybe you have used the researches that are related to this crops, crop models,
Yes, I've just used the results of their crop models. Now let's see, Australian, I've just forgotten his name. No, this will come back to me. He did a lot of modelling at CSIRO. Name's gone, but it'll come back.
Thank you very much.
You're welcome.
If anybody has any question, Andrea.
Hi, thank you for a nice presentation. I want to answer you about extreme events. They have increased.
y combined event especially. This year in Argentina, intensive drought occurring with fires. What about kind of action to prevent information anticipately? The problem is not a bad yet, as in annual crop, but biodiversity losses. Areas with grassland, agroenvironment are very affected by fires.
Yes, they are. We have that issue too, as they do in Australia, and we're losing a lot of biodiversity, and fires are very bad for that. So I guess all you can do is try and prevent them as much as possible. But we've had, in our case, we've basically had a lot of biodiversity loss because New Zealand never had mammals apart from bats. So with the arrival of European settlement, you got all the introduction of rabbits and with apologies to Sansol, possums from Australia, and they just really, both the fauna and flora weren't adapted to mammalian predators. So we've had, as well as that, but of course then you've got the climate changing and introducing other pressures. So really, when you look at climate and sort of agriculture, you have to also look at biodiversity. And I agree, Andrea, that's very important.
Thanks, Jim.
You're welcome. Is the sun risen yet?
If anybody has any question. So if not, Jim, I have a last question to you that
yes.
Whatever you have presented and you have mentioned different adaptations measures, but I was just thinking about the reality because look what Kumar has just mentioned, that 4 degree centigrade, particularly in the northern hemisphere. So what I feel that a very comprehensive kind of sensitization is required to put into place into the reality. And not only the climate activists or not maybe the extension, I think from the grassroots level, this sensitization program should be taken. And government should be very, very, very serious about this kind of implications. So what I feel that from the school level, if this kind of studies and its implications, because whenever it will be implemented by holistically. It's not that agriculture people will be on the field. It may be all the people who will be in the food chain. They should be integrated into the system and they should do the system. And whenever you introduce this thing in the school, though the students may be in the different streams, but they have a back in the mind that this has to be implemented in a very collective way. So, I mean, this is my, kind of proposition that if this can be started from schools and other from the beginning, I think then it could be a reality, because we have not a research now. We know that bichar or maybe whatever the adaptation you mentioned, but the main problem is the link between the research to the field. That is why I was mentioning that. What do you feel? How this kind of sensitization program can be initiated so that maybe 2100 it could be a reality? What do you think?
I agree. Well, I think this is probably the strength of the school system in New Zealand, because all our very young know all about global warming, and so these are the first schools, and so they're very motivated to do things about it. And it's because it's been introduced into the curriculum, we have far more activity, and of course it's the old story, the children affect the parents, and so it goes. So agree entirely.
If no question, thanks Jim for
You're very welcome.
giving a wonderful presentation, and in fact is an eye-opener to all of us. Maybe after this present, I will share the presentation to all of you.
Yep,
And those
very
who has not been present will present to the. I'll try to present across the world, I mean, this will be very helpful to rethink the strategy in their own countries, and also in some activities will be taking into that how this kind of propositions can be taken into consideration in the different countries around. That is why the meaning of this kind of webinar, is there. That's why we are trying to arrange this kind of emerging issues so that as a whole in globally we can people will be global users and global who are dealing with us will be benefited. Thank you, Jim, very much for once again, and we'll be looking forward for future interactions with you.
No, you're very welcome.
Okay, okay.
Yeah, and apologies for the technological issues at the beginning, but we got there.
Not at all, not at all. We enjoyed your presentation very much, and keep on give suggestions how we can improve the INSAM activities and ultimately the agriculture community in the world.
Yes, well, also I think we owe it to K-Stick to keep it going.
Yeah, right. So with this, we are closing here and looking forward to meet you again shortly.
Right.
Thank you, Jim, for the nice lecture.
Thank you. Yep. Thank you. And
thank you.
Yes.
Thank you. Bye.
Thank you. Bye. Thank you.
Thank you.
Have a nice afternoon.
Yes, well, it's not far from midnight. So